Our story begins with a cosmic roar, Earth's birth in fire and chaos. Imagine a world where the ground itself was liquid, and the sky glowed with the light of constant impacts. This was a time of unimaginable violence and transformation, the very beginning of our planet's journey. 4.5 billion years ago, the sun was young, surrounded by a swirling disk of gas and dust. In this vast spinning cloud, the seeds of planets were sown as gravity began its patient work. Gravity pulled particles together, forming clumps, then rocks, then planetesimals. These tiny worlds collided and merged, growing larger with every impact, shaping the early solar system. These bodies collided, merging in a spectacular fiery dance, forging the planets, including a molten, hellish Earth. Each collision released tremendous energy, melting rock and metal, and adding to the planet's growing mass. The surface was a sea of magma, bombarded by asteroids and comets. The relentless impacts kept Earth's surface in a constant state of turmoil, reshaping the landscape again and again. No solid ground, no water, no breathable air, just a toxic haze vented from the planet's interior. Volcanic eruptions filled the sky with poisonous gases, making the air thick and unwelcoming. Then a cataclysm, a Mars-sized protoplanet, Theia, smashed into Earth. The collision was so powerful it nearly destroyed both worlds, forever altering Earth's destiny. The impact tilted our axis, set our seasons, and blasted debris into orbit. This debris formed a glowing ring around the planet, a spectacular sight in the young solar system. That debris became the moon, whose gravity stabilized Earth and created tides, crucial for life's future. The moon's presence slowed Earth's spin and helped create a more stable environment. As chaos subsided, Earth cooled. A solid crust formed, floating atop the still molten interior, providing the first foundation for the world to come. Volcanoes erupted, releasing water vapor and gases, slowly building our early atmosphere. Over countless millennia, these eruptions transformed the air, making it possible for water to eventually collect. Eventually, the planet cooled enough for water vapor to condense. Rain fell for centuries, filling basins and craters, forming the first oceans. These endless storms sculpted the land and filled the world with water. These primordial seas set the stage for life's first appearance. In their depths, the ingredients for life began to mix, awaiting the spark that would change everything. From cosmic violence, Earth emerged, scarred but transformed, ready for the next chapter in its incredible story. For countless eons, Earth was nothing more than a desolate world of rock and water, its surface battered by meteorites and shaped by violent volcanic eruptions. There was no sign of life, just a silent, empty planet beneath a hostile sky. The planet was bathed in harsh, ultraviolet light, with no protective atmosphere to shield it from the sun's relentless rays. The environment was unforgiving, and the oceans simmered under the intense energy pouring down from above. Yet, deep within the primordial oceans, something extraordinary began to unfold. Simple molecules, energized by lightning and volcanic heat, started to assemble into more complex structures. Against all odds, the first self-replicating life emerged. Tiny, fragile, but persistent. Around 3.8 billion years ago, single-celled prokaryotes, bacteria, appeared. These ancient organisms thrived in environments that would be utterly lethal to most modern life, adapting to extreme heat, acidity, and pressure. These early anaerobes drew energy from chemical reactions, feeding on minerals and gases near hydrothermal vents. For over 1 billion years, they multiplied in the dark, silent depths, slowly shaping the chemistry of the planet. Then, a true revolution occurred. Cyanobacteria evolved the ability to harness sunlight through photosynthesis. They used this energy to make food, releasing oxygen as a byproduct and forever changing the world. The Great Oxidation event followed, flooding the atmosphere with oxygen. This new gas doomed many anaerobes, but it also paved the way for the evolution of more complex life forms. As oxygen levels rose, the ozone layer formed high above, shielding Earth from deadly radiation. Shallow seas became safe havens, and eventually, even the land would become habitable for life. Oxygen also enabled a new, more efficient way to generate energy: aerobic respiration. This breakthrough allowed organisms to grow larger and more complex than ever before. Fueled by this energy, eukaryotes, cells with nuclei and specialized organelles, evolved. This set the stage for the next great leap in the story of life. From these simple beginnings, life was now ready to diversify, branching out into an astonishing array of forms that would one day fill the oceans, land, and sky. After billions of years of single-celled life, evolution erupted in the Cambrian explosion, 541 million years ago. In just 20 million years, nearly all major animal body plans appeared, the oceans filled with trilobites, anomalocaris, hallucigenia, and other bizarre creatures, predators and prey in complex ecosystems. Rising oxygen, new habitats, and the evolution of predation sparked an evolutionary arms race, driving rapid diversification. Hard shells, exoskeletons, and complex eyes emerged, laying the foundation for all future animal life. The Cambrian seas were a dynamic arena of swimming, crawling, and hunting. This explosion established the blueprints for the animal kingdom. Life was now big, complex, and wonderfully weird. The stage was set for the conquest of land. For millions of years, life was ocean-bound. The vast, mysterious seas were the only home for all living things, sheltering a diversity of creatures that would one day change the world. The land was barren, until the ozone layer made it habitable. With the formation of this protective shield, deadly solar radiation was blocked, and the stage was set for a dramatic transformation. The first pioneers were plants, brave colonizers that crept from the water's edge onto the empty land. Descendants of green algae colonized damp shores around 470 million years ago, slowly adapting to life outside the water. Early land plants evolved roots, vascular tissues, and new ways to draw nutrients from the earth. They developed waxy coatings to survive and spread, protecting themselves from drying out in the sun. Over time, these plants transformed bare rock into lush green landscapes, creating the first soils and habitats. As plants spread, they pumped oxygen into the air and created soil, making the land more hospitable for other life forms. This paved the way for animals, who would soon follow in their footsteps. The first land animals were arthropods, creatures like ancient millipedes and scorpions, venturing onto land to feed on decaying plants. These early pioneers were soon joined by vertebrates, lobe-finned fishes like Tiktaalik, with features of both fish and amphibians. With strong fins and primitive lungs, they could survive in shallow waters and even wriggle onto muddy banks. These remarkable creatures ventured into new territory, bridging the gap between water and land. These fishopods were the ancestors of all tetrapods, amphibians, reptiles, birds, and mammals, ushering in a new era of life. Their descendants would fill every corner of the land, from forests to deserts. Life had finally set foot on solid ground, forever changing the course of evolution. The conquest of land transformed Earth's surface forever. New ecosystems flourished, and evolution accelerated, giving rise to the incredible diversity we see today. The journey from water to land was complete, a turning point that shaped the world as we know it. After the migration to land, reptiles evolved the amniotic egg, freeing them from water and allowing them to conquer dry continents. Following the Permian-Triassic extinction, dinosaurs emerged and rose to dominance. Early dinosaurs were small and agile, but their upright stance made them efficient and active. As climates shifted, dinosaurs diversified, filling every ecological niche for over 150 million years. The Mesozoic era became the age of dinosaurs. Giant sauropods, armored stegosaurs, and fierce predators like T-Rex and Velociraptor ruled the land. Herbivores browsed treetops. Carnivores hunted with power and speed. Dinosaurs adapted to every continent, becoming the masters of their world. Their reign shaped ecosystems and evolutionary paths. For tens of millions of years, Earth belonged to the dinosaurs, but their dominance would not last forever. 66 million years ago, a massive asteroid struck Earth, ending the dinosaurs' reign in an instant. The impact unleashed firestorms, mega tsunamis, earthquakes, and a shroud of dust that blocked sunlight. Photosynthesis halted, plants died, and food chains collapsed. Herbivores starved, carnivores soon followed. Global temperatures plummeted. 75% of all species vanished, including non-avian dinosaurs, marine reptiles, and flying pterosaurs. The world was reset, an apocalypse and a new beginning, but extinction is also opportunity. The survivors, small, adaptable creatures, would inherit the Earth. The age of dinosaurs ended, but life's story continued. From the ashes, new forms would rise. The next era belonged to the mammals. In the dinosaur's shadow, mammals had survived as small, nocturnal creatures, warm-blooded, furry, and adaptable. When the asteroid struck, these traits became their salvation. Mammals endured the cold and darkness, needing little food and sheltering underground. With dinosaurs gone, mammals rapidly diversified, filling vacant ecological roles. Some returned to the seas, others took to the trees, and some grew into giant megafauna. The Cenozoic era became the age of mammals, leading to primates, apes, and eventually, hominins, our direct ancestors. The fall of dinosaurs enabled the rise of mammals, and ultimately, humans. Evolution's winding path led from shrew-like survivors to Homo sapiens. The asteroid's devastation cleared the way for our existence. The story of life had entered a new chapter. The journey from mammal to human had begun. Dinosaurs are not entirely gone. One remarkable group survived the cataclysm. Birds are living dinosaurs, descendants of small feathered theropods. Fossils reveal feathers, wishbones, and bird-like skeletons in non-avian dinosaurs. Behaviors like brooding on nests link birds to their ancient ancestors. Feathers likely evolved for insulation or display before flight. Birds' small size, flight, and beaks helped them survive the extinction. Every bird, from hummingbird to ostrich, is a living branch of the dinosaur family tree. When you see a robin or a pigeon, you're witnessing a modern dinosaur. Their songs are echoes of a lost world. Dinosaurs live on, a testament to life's resilience and adaptability. Earth's history is a cycle of change, extinction, and renewal. Mass extinctions cleared the way for new life, shaping the world we know. Today, we face a sixth mass extinction, this time caused by us. Human activity is driving species to extinction at unprecedented rates. The story of extinction is now our story and the challenge of our age. By understanding the past, we can better protect the future. Join us as we explore lost worlds, celebrate survivors, and learn from Earth's epic tale. The journey continues. Let's uncover the secrets of life, extinction, and survival together.